Hey again, good morning to all. So last time we ended with, if I'm not mistaken, sa katong pag-develop sa HDL for MUX 8-way 16, which would be this one. Compare file mo din eh. So sa itong HDL ani. Diba? Okay. So ano I think sa inyo hanigikan, ako na copy. Kaninga parts code. This is from codes that you have developed. So together with the others. So tulong to ka-other akong ipabot sa inyo ha. I have other, this one. Sa inyo gihapon eh. Full other, this one, which will utilize a half other and an OR gate, right? And 16-bit other. So can I say, compare mo ni. So can I say inyo gihapon gikan. So again, I commend each one of you, to those who have submitted. You did a good job sa pag-develop sa code for HDL files for those 4 chips. The MUX and the 3 others. Okay. Diba? So let's try to simulate. If not already, I'm sure gi-simulate man to ninyo ang inyong mga gipang develop ng chips. Again, how will we do it? Let's load our chip. Let's say for example half other. The half other, and it's script half other. Diba? So yan mo to button, diba? Click run. Kung successful na mag-prompt sa silong, dili bottom right na part. O comparison ended successfully. Okay? After ana, magawas nga output file here. Half other man to, diba? So the output file, which would look exactly like the compare file. Diba? Kung successful siya, so pala itsura. That is if we'd like to simulate it using the script. Pero what if, like previously, manual siyang simulation, which is okay nagyapon. So let's write the full adder. Diba? But if we'll simulate this one, there's not much that we can do. Because we've studied this circuit before, siguro even last semester. 1 bit naman po ang iyang i-accept as input. Okay? So natay tulo ka inputs here, input A, input pin A, input pin B. Input pin C is the carry na pin, diba? So 1 bit naman kahit na maka-perform og mga meaningful na mga calculations here. So let's try to simulate the other one daw, the add 16 na other, the one that you develop also. So this would accept 16-bit inputs. I'm not sure if inyo ning na try or inyong explore or gidulaan ang hardware sim. Pero pwede ba ata ang input here is decimal or binary. So ang default, once we open hardware sim, is naka-decimal ang format sa itong input. Right here, decimal. So pwede po dahil binary. If gusto tag binary na input. So if 16 siya, 16 bits, all in all, so if cater po ng mga negative numbers, so natunga na itong 16, so 8. So 2 to the 8, how much is that? 2 to the power of 8. Pili ba na siya? 2 to the power of 8. So 256. So This is not 2 to the power of 8. 8 bits man siya. So 256 lah. Let's try 512 daw kung mo dapat siya. 16, 8, 512 plus 512. Try lang ako niya. So dili siya, dili 512 ang highest number. So pila ba? Well, anyway, no? So pwede siya decimal numbers ang atong ibutang nga input. No? I could not remember right now kung pila ang iyahang maximum value nga pwede ibutang as input. But yeah, pwede decimal. No? So kasi naka-try bitaw ta before nga di manual nato nag-simulate then buta ta 10 10 10 10 then dili siya mo dawat. That's because naka illegal value na nasa prompt sa silong. Pinaka-decimal pa man ang format. So pwede man po siya binary. Diba? No? So these are 16 bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just as how we designed it, right? 16-bit na input. Pero I think mas convenient magyapon ng decimal. So we'll try to simulate again our add 16 circuit. Add 16 chip, I mean. Add 16 HDL file. Our adder that accepts a 16-bit input. So what if, mas simple calculator, di ba? Maka-perform addition, pwede niyang mabuhat. Let's say for example, 20. So 20 plus 30, we know nga ang output ani would be 50. So kita niyo class, it's 50. No? So what if 0 and 30? 0 plus 30? Of course, 30. Pwede negative, pwede negative. Let's say negative 9 and 30. So pila yung output ani? 21, no? Positive 21. So single step, click, 21. What if duha ka negative numbers? Negative 5. So negative 9 plus negative 5. Alam siya, negative 14. So single step, negative 14. So kani, this is how this is the output sa atong simulation if we do a manual na checking. Any arbitrary value, pwede mga ito iputang din. So, pwede decimal, pwede po binary. So, muna siyang binary equivalent for negative 9 and binary equivalent for negative 5. So, 16-bit. This is the 16-bit na adder. Okay? So, we added 4 new chips sa atong folder. I also made another one, a new chip that we'll call INC16. No? So 16-bit Japan yung input. So INC because it's literally called an incrementer. Okay, incrementer. Malagiya lang yung button is mag-add lang siya og 1, no, to any input. Any input, plusan lang niya og 1. So basically, malagiya yung button. No? Any input, it will accept any 16-bit input and plus 1 lang niya. So that's what the incrementer does. If we'll try to look at the compare file of the incrementer, yan iyahang itsura. No? Notice, if yung input is all zeros, yung output is all these zeros will be added by just a 1. So muna yung output. So what if all ones yung input? So supposed to be the output of this one is 1, then followed by 16 zeros. Okay? But tungod kay overflow ni siya, overflow na 17 bits na ni siya, hindi na siya display sa atong simulator. That's why ang output sa incrementer, if the input is all ones, should be all zeros. So what if ang input is 101, the output would be 110. So giplasan lang yun og 1. That's the purpose of the incrementer. So unsa itsura sa atong incrementer in terms of HDL file. Wala. Sa inyo na-observe. What does this look like? Notice na almost exactly the same siya sa inyong gibuhat na 16-bit adder. Wala. So ato i-compare mo ni inyong 16-bit adder. Wala. So akong ibutang diri ang 16-bit incrementer, wala kayo kalahian sa codes. Ito na ko ha. Wala kayo difference, di ba? It's because I based this 16-bit incrementer sa inyong gibuhat na 16-bit adder. Ang difference lang is it will only receive one input in, and of course ang output is isa ra pod ka terminal, but 16 bits gyapon, so output. Instead na ang input is A is equal to A0, mo man ang original sa inyong 16-bit adder. Yan ang akong gibuhat, no? A is equal to in0, A is equal to, for the first half adder, its A terminal is in 0. For the first full adder, its A terminal is in 1, and so on and so forth. Ang B, then, is either, ibutang na ako 0 or 1. Or actually, 1 sa first na B, sa half adder, then 0 na yung tanan. Pero notice ang syntax na akong gamit. Okay? For 0, for this kind of HDL na atong gibuhat, ang atong ginagamit, I mean, for this kind of HDL that we're utilizing, ang syntax sa iyahang 0 is a false. Okay? Take note ha, if we'd want an input of 0 sa atong HDL na code, buta na to as false. And if we'd want an input of 1, true. Okay? So for all the full adders, ang B na terminal is nakaset as false na, nakaset as 0, except sa first na B terminal sa half adder, which is true, or 1. So, meaning, nakakascade man sa tanan ba? Meaning, it's as if gi-plusan lang yun og 1. Ang first na bit, first na digit sa input, i-plus og 1. Okay. Then the same na gyapon iyahang code sa all the others. So again, try to look at this one, study it. The same na siya sa inyo, add 16. No? Almost the same, I mean. So atong ikuan daw, simulate. Simulate na ito. 16. 16. Nago ko i-script ani. Nagyapon. No? Successful man yun noon eh. Ako na-try earlier. Okay, successful. So what if manual? Manual na to simulate. Format, let's change this to decimal. So what if atong input is 5? 5. So yung output, of course, we expect the output to be 6. So plus 1 lang. 6 siya. Right. If atong input is 20, output is 21. 21. If atong input is negative 7, output is negative 6, supposed to be. Yeah, negative 6. So that's the purpose of the incrementer or Inc 16 chip. Ito. Plus 1 namin siya. Okay. So I'll just pause right here. And so far, is there any questions? I proceed to the next topic if wala any question. No questions, Josh?
Wala, sir, wala.
Okay, sige. So, I hope nasabtan na to, no? Good ako kung nag-check and nag-simulate sa atong gibuhat so far. So, I'll introduce a new topic this morning. So, our topic is on the Arithmetic Logic Unit, or ALU. So, doon na gid ta, no? Kung ako ang pangutanon, more than half na sa atong dapat i-cover. And because the ALU, or the Arithmetic Logic Unit, is a very big part of any microprocessor. Or all kinds of microprocessors, of course. Halos tanan mo siguro nga microprocessor nga exist right now, nagyo iyang own na Arithmetic Logic Unit. So the Arithmetic Logic Unit is sort of like the muscle of the microprocessor. No? It performs all the most basic calculations. And what calculations are these? The arithmetic calculations and the logical operations. So arithmetic, like add, subtract, multiply, divide, pwede. Logic operations, and or not, and all of those Boolean operations that we've covered before. So all of those could be performed by the Arithmetic Logic Unit. So as I mentioned earlier, all microprocessors, at least according to the von Neumann architecture, contains not only a control unit but also an arithmetic logic unit, or ALU. This one right here. So kaning block diagram that we are seeing right now, this is the block diagram of a computer, an actual computer or actual computer system. Input device, output device, memory, and inside this processor is our microprocessor, or the central processing unit, CPU. So one of the main components of the CPU is, of course, the ALU, Arithmetic Logic Unit. So ato na siyang i-dissect, then zoom in ta. This is the standard schematic diagram for the ALU. So yung mga input terminals here ay PAT, no? This has 4 input terminals. A terminal and B terminal, both are operands, meaning ang operand diya nato isulod ang atong data, no? Basically ang atong ones and zeros, no? So let's say for example 4-bit na siyang ALU. So example lang, dili kayo complicated. So atong operand would accept inputs such as 000 to 1111. So muna siyang range value sa atong operand. So arbitrary values depende sa gi-give sa input device. Let's say for example keyboard or mouse or data gikan sa internet na download or whatever, di ba? So ito natin na sa islog sa operand. We also have status input. If it accepts, if isa sa iyahang mga basis is the status of another device na connected to it, maybe connected po din to sa another ALU, because isa po sa output, possible output sa atong ALU is a status output also, no? So mga status inputs and status output na sila. But ang main na to delay of concern, at least as of today's discussion, is the operands and the opcode, no? Or operation code. So this opcode, let's say for example, also accepts four bits of 4 bits gyapon natong opcode. Let's say for example lang, 3 bits na lang para dali, no? Let's say 3 bit natong opcode. So pila man na siya, 2 to the 3 is 8. So gamay naman kayo, no? Wala ALU nga na, pero this is just for the sake of argument. So ang opcode, if 3 bits siya, so pwede siya mo receive og inputs from 000 to 111, which is 8 ka buok. So pwede siya maka-perform og 8 ka operations. Then, no? So opcode means code for the operations. No? So na siya 8 ka buok, 3, 4, 5, 6, 7, 8. Pwede nga iyang first operation is it could perform addition. Pwede ang second is subtraction. Pwede ang third is multiplication. So on so forth. Pero 8 lang ka buok. No? Pero again, wala may 3-bit nga opcode terminal. So if 8-bit ni siya, so 2 to the n, 2 to the 8 operations yang pwede ma-perform. So whatever is ang number of bits nga pwede accept sa atong operand, and of course, uniform na sila, mao ang number of bits sa output. Okay? So more lang siya og kanang so far lang ha, so far. We could think of it as a black box, no, or magic box, that if we do not know the inner circuitry of this one, mao siya atong calculator, no? So let's say for example, atong opcode, no, is let's say 010, and sa iyahang lookup table, 010 means or denotes addition, no? So if atong input sa A terminal is 111, then sa operand is 001, and atong opcode is 010. So i-add lang na niya. No? So i-add na niya. Meaning atong output would be overflow siya, no? So 1111. 4 bits na lang natin na pala. Sigurado. Yan. So it's as simple as that. Yan na lang gid ang conceptual na function sa ALU. So iyahang mga possible na operations mo perform is stored sa opcode, no? So operations are already defined, no? Are predefined by you, the designer. Predefined. And of course, ang inputs are both arbitrary. No? Arbitrary inputs. Tama na ito ni. Kung 8-bit ang both inputs, dapat 8-bit pa lang output. Okay. So there are, of course, numerous ALUs that is existing in the world right now. If we will try to design a real world na ALU, that would take us a plenty amount of time. Okay. The nicer it is, the more difficult it would be, no, to design an ALU. So pwede na punta, no, for this subject, we'll try to design a very simple na ALU. Okay, so these are our ALU. I mean, this is our ALU with these inputs and outputs. So for the input, we have X and Y, which are 16 bits both. Atong output, out terminal, 16-bit gihapon. And atong opcode na pins, input pins, kay 6 kabuok. So ZX, for this simple ALU of ours, let's define our opcode terminals as ZX, NX, ZY, NY, F, and NO. No? So kung anong kana nga mga letters itong gigamit, we'll appreciate it in a short while. No? Kaning duha ka output terminals na mga output ni sila. Sa very bottom, these are the status terminals. No? Status output pins. Status. And ZR and NG. So later na sila. Yan na. So pila man ni kabuk nga opcode pin 6. Supposed to be, it's 2 to the 6 number of operations na kaya niya nga ma-perform. So, 64. 2 to the 6. 64, no? So theoretically, we could define at most for this simple ALU of ours, 64 operations. No? Pero magdagan na sila kayo na siya. We'll just start with 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's start with just 18 operations. No? And what operations are these? So for any given input, these are the possible outputs. May output nga 0 lang. May output nga 1 lang. May output nga -1. May output nga X only. Doesn't matter kung sa gibutang sa Y. Yung output is just X. May output nga Y only, no? Vice versa. And so on, so forth. Kaning exclamation point, this refers to inverse, no? Or not operation. Putang na ko sila dili, no? For note. So not operation na siya. So of course we know what this one, negative. And this one is addition. So sa Boolean natong algebra sa mano-mano bitaw natong analysis class, di ba mo ni siya ang symbol for the and. So it's not so for our HDL. It's not so for our HDL. This one is addition, okay, or sum. Ang and is the ampersand symbol. Ang or is this one. And of course, ang plus symbol is summation. So these are the notations that we'll be using for our 18 opcodes. 18 sa book 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah. Okay. Okay, let's specify this for further. So this is not necessarily a truth table, no? This is just a specification table, perhaps. 18 man to kabuok. So look at the table closely. Ito na i-divide into 2, no? Para kung focus your attention sa left part, sa red na dividing line. So these are the 18 possible opcodes na available. No? So wala man noon diya tanan possible na combinations for the 64 possible outcomes. So, say for example, wala man diya ang 111111. Yeah, wala. So even kanyang 000000, wala man sad. So we have specifically chosen these possible inputs para ma-perform efficiently ang atong intended nga output. Na day 00. So na 000000. Wala lay 11. Wala 1 tanan. Yeah. Wala. So okay. So before na ko explain, mas siya kasi if yan eh, no? So ito symbol sa ALU. So before na to i-explain pa further, let's say for example, symbol niya. Okay. So muna input, muna output, muna opcode. So i-ignore na to as of this time ang status outputs. Let's say for example, the input is 0, 0, 1. 3 bits lang. Their input is 0, 1, 0. So if we want our ALU to perform an addition, so this is X, this is Y, meaning we want it to perform addition, X plus Y, and atong desired output is 0, 1, 1, right? Meaning atong opcode should be asa siya sa rightmost na column. Diba? No? So mo dapat na yung atong opcode na input 0, 0, 0, 0, 1, 0. So 0, 0, 0, 0, 1, 0. Yan na dapat. Okay? Okay, na pod. Another example. What if ang atong input is 0, 0, 1, 1, 0, 0. Diba? 0, 0, 1, 1, 0, 0. So unsa man na siya? It's this one. 0, 0, 1, 1, 0, 0. Meaning the output is X. Meaning ma-predict na to. Yung output would be 0, 0, 1. Ignore si Y. Okay. Because ang atong opcode is 0, 0, 1, 1, 0, 0. Okay? So conceptually, that's how a very simple ALU works. So before I go further, any questions? May pangta na class? Sabtan na ba basically ang ALU? Sa part na libog na, don't hesitate to ask questions. So if okay na to, so let's specify even further of what's happening there in the inside. No? Sa kakitabo sa sulod. sa ALU na to. Why can it perform those operations? Okay. So na sa taas, this describes what's happening for each possible input sa atong opcode terminals. No? So ang possible na inputs lang again class is just a 1-bit na number, either 0 or 1. No? So for example, dili siya para sa input na mo accept og 16-bit na inputs, 16-bit nga value. For each opcode terminal, 1-bit lang. No? Meaning, either 1 or 0 lang iyang i-accept na input. So for example, what would happen if na ay 1, no, sa ZX terminal? And also, before I go further, ang sequence dayani sa input is from left to right. No? So si ALU, ang pinakaunan niya nga tan-awon is ang input kay ZX nga pin taman kay NO. So si NO ang pinaka-last niya nga tan-awon. So ang sequence niya ni is from left to right. Okay. So what would happen if ZX is 1? So na dire. So if ZX is true, dapat ni. So if ZX is true, then i-convert niya ang input X into all zeros. Okay? So example. Itong ALU. So ang ato lang dire is si ZX lang ang 1. Okay? So si ZX lang ang 1. So 1, 0, 0, 0, 0, 0. So if X is, let's say for example, arbitrary value nga 1, 0, 1, 1, 0, 1, and si Y is 0, 1, 1, 0, 1, 0. If ingani ang input, or at least if 1 ang ZX na opcode input, i-convert niya ang input from any arbitrary value into pure nga 0. Yan ang may tabo. Okay? So again, first column, if ZX is true, then X is equal to 0. Next. So next. So yan na yung process. Last CNO. Okay. Last gani symbol. So if ZX is 1, X is 0. What if ZX is 0? Ignore, no? Meaning as is ang values. Next, what if NX is also 1? No? So if NX is also 1, ang iyang buhaton sa X input is iyang i-invert. Diba? Exclamation point, invert. So, meaning, what if both zx and nx are 1? Just like this opcode, if atong original nga x is arbitrary as 1, 0, 1, 1, 0, 1, example lang. So, i-convert na niya to 0, 0, 0, 0, 0, 0. If nx is true, notice i-invert niya. So, i-convert niya ang all zeros into all ones. That's what would happen. No? But if nx is 0, it's 0 ni, ignore, no, as is. So that is the presetting of the x input. Okay. Next is the presetting of the y input, which is the same gapon. If zy is equal to 1, then convert niya ang y into all zeros. If ny is also 1, convert niya ang y into the inverse, which is 1, 1, 1, 1. No? Meaning, like sa atong ALU, so what if 1, 1, 1, 1 na siya ang opcode, then dili 0, 0 lang sa. So all ones, meaning, first, i-convert niya ang x into all zeros. And then, i-inverse niya ang x. Tungkol kay all zeros siya, ang inverse niya kay all ones. Next is y. Convert niya ang y into all zeros. Next is convert niya into all ones. So that's what would happen if the first 4 MSB of our opcode is 1. Yan na. Wala pa nahitabong output. Okay? Wala pa nahitabong output. I-convert lang niya ang mga inputs so far. Okay? So after presetting x and y, naman ta, one ang first 4 columns, ang f na lion. No? So computing either a sum or an end function. So if f is true, or if f is equal to 1, then the output now is x plus y. Or is summation niya, isum ang x and y. But if f is equal to 0, else the output is x and y. Okay. So dire, if ang f ng opcode is 1, i-add niya. But if the opcode is 0, after presetting x and y, is as if may mo siya og AND gate. I-AND niya si x and y. So computing either a sum or an AND function. Last, post setting the output. If NO is true, then the new output would be the inverse of the previous output. So whether the summation nato, the sum nato or the end, if 1 ang NO, i-invert na to ang final output. If dili, no? If NO is 0, as is. Okay? So that's what's happening inside our simple na ALU. So with these possible na opcode operations, Ano siya mga expected na output. Okay? Sige, example data. Let's try to solve some example. Solving, no? Element solving. It's just a demonstration. So itong opcode, eh. Let's try an opcode of 001101. Ang X na to 1100. 4 bits lang sa, no? Ang Y is 1011. Na. So, mag-drawing tag-actual nga ALU. It's as if this is what's happening. Step-by-step data. Step-by-step. Six steps mo siguro ni. No? So, yeah. First opcode, 0. No? So, if 0, what would happen? If Zx is 1, then X is 0. But if Zx is 0, as is Cx. So, Cx is as is. X is still 1100. Next opcode. Abutan lang ako, dili na lang sa 1. 001101. If nx is 1, then invert. But nx is 0 man gihapon, so I think as is gihapon siya. X is as is. About y. So y is 1011. But the zy opcode is 1. So if zy opcode is 1, y is converted to all zeros. 2, 3, 4. That's the new y. Next, the fourth opcode, ny, is 1. Okay, and 1 siya. So, cy ang is i-invert. So, ang invert sa 0, 0, 0, 0 is 1, 1, 1, 1. That's the new y. So, next, fifth step, deciding between sum or end. So, if f is 1, then sum. But f is 0, so end operation. So, x and y. So, what would happen if ito ng input? Saka end gate. 0 man siya tanan, no? Bit by bit man eh. And ani, and ana, and ana, and ana. So I think the output is 0, 0, 0, 0. Ay, sorry. Y mo ni de. X mali na to is na as is mali ay. So 1, 1, 0, 0. Si Y now is 1, 1, 1, 1. Output is 1, 1, 0, 0. That's the second last step. Last step, post setting the output. If NO is 1, then the output is inverse. The output is inverse. So the new output, or the last output rather, is ang inverse ani, which pagi na to sort of AND gate. I mean not gate. So the new output is 0, 0, 1, 1. Output 0, 0, 1, 1. So ato na i-summarize. So 0, 0, 1, 1, 0, 1. First na input is final output is 0, 0, 1, 1. Which is this one, diba? So in the end, magically, no, napadalong nagyapunta sa ingani nga operation, not X. No? Sakto ba? Is this output the NOT of this input, ignoring Y? Padalong gyapunta, di ba? Sa NOT of X, which is 0, 0, 1, 1. So that's what's happening inside our ALU. Okay. So another example, last one siguro because it's already 12. Pero let's do this quick lang because, well, di man nato need na i-step by step this time. Pwede lang natutunan sa lookup table. No? So atong opcode this time is, let's say, 0, 0, 0, 1, 1, 1. Ano atong opcode? Ito X, arbitrary value, 0, 0, 1, 0. Atong Y, 0, 1, 1, 1. Okay? So ato sa pangitaon, asa ni siya? No, 0, 0, 0, 1, 1, 1. It's this one. 0, 0, 0, 1, 1, 1. So meaning the output is Y minus X. Kung i-subay niyo ni class, step 1 to step 6, I'm sure we'll end up with this answer. Y minus X. So i-subtract na siya. What is 0, 0, 1, 1, 1? This is 7 man, di ba? This is 7. Kani, this is 2. 0, 0, 1, 0 is 2. So kung i-subtract na ito na siya, 7 minus 0, so 5. What is 5? 0, 1, 0, 1. i-try galing ninyo. No? Try ninyo nga i-step by step ni. I'm sure we'll end up with this answer, 0 and 0, 1. Okay. Just by looking at the given, ang x is as is, ang y wala gi himong 0 but gi not. This is a summation, sum operation, and another inverse. Yeah. So kung with practice, I'm sure makuha na ninyo ang internal operation sa ALU. But not necessarily na ato ginang subayon tanang tagsa-tagsa. Just like the ALU, mo refer lang na siya sa iyang lookup table para makabalo siya sa ang operation nga i-perform. No? So first niya tanawon is iyang opcode. No? So pangitaon niya sa iyang 18 preset or predefined na operations asa mo tugma. So for example, number 2, it's this one. So mag-perform siya og addition. Subtraction. Okay. So I think we'll end here. Any questions?
Sir, one question, sir.
Yes.
Na lost ko sa example 1, step 3, sir. Nganong diretso ni 0 all CY, sir?
Okay, sige.
Paspas
So,
sir.
sige. Good question, Josh. So nganong na 0 tanan si Y is because si opcode nato sa kana nga input is 1. No? Diba? Balik dire. So if ZY is 1, automatic Y is 0. No? Or 0, 0, 0, 0. Depende kung pila ka bit.
Okay, sir. Thank you, sir. Wala ko na nakita, sir.
Sige. So originally, mo man yung atong Y nga input. So i-ignore na niya and then i-convert na niya na to all zeros. Okay?
Okay, sir.
Sige. Any more questions? So if there are none, anyway, you could review man our video. Pero if na po may mga questions along the way sa inyong pag-review later, pwede naman ko niya i-PM no, for more inquiries. Pero we'll end here this morning.